Hi, welcome to today's video in Helius's Solana Frontend Developer course. In today's video, you're going to learn how to build an application that lets you fetch and put data on the Solana blockchain. In this process, you're going to be learning how to serialize and deserialize data from the Solana blockchain. My name is Nathan Galindo. I'm a developer experience engineer at Helius. I'm based in Texas, and I'm a full stack Solana developer. So please feel free to reach out to me on X to ask me any questions about Solana, Helius, or this course. In today's video, we're going to have an overview of the project that we're going to build. We're going to learn about key concepts on Solana, such as the account model. And finally, we're going to build the project together. Awesome. So let's begin today's project. Now I'm going to assume that you have the course app installed and every other dependency and other tool you need to follow along with this video series. If you do not, I highly recommend you visit video number 2 of this video series, where you'll be able to download everything you need to follow along with this course. Assuming you have everything you need, I'm going to go ahead and get started. Go ahead and open your repository and run the app locally using the command yarn dev, and then open localhost :3000, and you should see an app that looks something just like this. Now, once you have this app open, what I want you to do is navigate to project number 4. That's project Serialize, and click on preview. Okay, and once you have this course app opened up, what I want you to do is go ahead and connect your Phantom wallet. Now remember that your Phantom wallet has to be on the testnet, and you need to have some amount of DevNet Sol. It doesn't have to be a lot. You can see I have 0.1 DevNet Sol, and that'll be just enough for this use case. And what we're going to do is we're going to fill out this form. So I'm going to type in my name, Nathan, and what brings me to Solana, the meme coins, because who doesn't love meme coins? And once we have that information up, we're going to go ahead and click submit. We're going to sign for this transaction. We get a notification that our transaction was successful, and just like that, if you scroll through this paginated interface, you might be able to find my message somewhere within these submissions, but I'm not gonna waste time looking for my message. That's essentially how the app works. Essentially, we are typing in this input form, then we're going to serialize our inputs, submit that to a custom on-chain program that we will talk about more in a little bit. And then that program is going to create what's called a program derived address account, a PDA account, where it will store our submission basically forever. So that being said, I do not have control over these submissions. The program has control over these accounts on the blockchain. So they're kind of permanent. So when you use this app and you submit your input message to the blockchain, I highly recommend you be careful with what you say. Don't say anything inappropriate, because that's not going to go away, and maybe you might regret that later. Okay, public service announcement aside, what I want you to do is I want you to open up your folder structure for the course app, go into models, serialize, and then open up the student intro reference and the student intro. And I'm actually going to flip these just like that. Fantastic. So what's happening here? Why are we opening up these two files? Well, simply put, because we are submitting like custom data to the blockchain, right? Like this custom data structure that we're defining, we have to create a structure for that data. So that way, when we serialize it, it's in structured form. And then when we fetch it from the blockchain to render on our application, we can restructure it and show it the way we originally intended, essentially. And so this is kind of what that looks like. So let's go ahead and build that out now. We're gonna create a class. So this is some object-oriented programming for those of you that might be new to that. And we're gonna initialize these two variables, name and message, right? Why? Well, because we're submitting our name and a message, right? Some thoughts. In fact, if we want to be a little bit more semantic, you can title that thoughts if you want, but I'm just going to go ahead with the predefined example. Now we're going to use a constructor function. We're going to pass in those two parameters, name and message. We're going to open up those curly brackets and we're going to initialize those two variables just like so. Now, what are we doing here? Borscht instruction schema. We're creating a schema using the Borscht library to basically create a structure using this data, right? We want this data to be in a structure or in a struct when we submit to the blockchain, so that way when we retrieve it, oops, my typing is not going well. So that way when we retrieve it, we can restructure it. Equals borscht.struct, open up those parentheses, open up a pair of brackets, and we're going to define a variant, a string value of name, and let's go ahead and add those commas, and then another string value of message. Okay, and now we're gonna create a static item called Borscht account schema. We're gonna use Borscht again. We're gonna use struct again, open up those parentheses, open up those brackets. And again, we're gonna create a U8 item called initialized, a string item for our name, and another string item for the message we're submitting to the blockchain. Fantastic. And now we're going to create two functions, one to serialize our data, and then one to deserialize our data when we fetch it from the blockchain. So we're going to create a buffer of 1,000 bytes. And then we're going to encode that buffer like so with those items. And then we're going to pass in the buffer that we initialized essentially. So this is encoding this information, this being the name and the message, and then our variant, and it's encoding that and storing that within this buffer variable that we created right above it. Now we're going to return this buffer, but we're going to slice it to the span of the buffer that we created, right? So what's happening here? Well, essentially, we don't want to submit all 1,000 bytes, right? If we don't need to. So essentially what we're doing is we're just slicing the length of the buffer of our message and submitting that to the blockchain. So that way we're not wasting space, right? Because, the name Joe is shorter than the name Nathan, and the message hi is shorter than the message hello, and bitwise. And so this way, we create buffers that just don't take up as much or too much unnecessary space. So now let's create a static function that we're going to call deserialize. And it's going to take a buffer possibly. And then we're going to pass in this reference student intro. Actually, no, student intro or null. So it'll return an instance of student intro or null. And what exactly is going to happen here? Well, if there is no buffer, then we're simply just going to return null. Otherwise, we're going to extrapolate the name in the message. We're going to decode that information from the buffer that was passed into this function, and then we're going to return a structure including the name and the message. Now, if this process fails, then we're just going to log that error like so, and we're going to return null. Okay, fantastic. So I hope that makes some sense. If not, I've left some notes up above the reference file for your reference, hence the name. So go ahead and give that a look, and maybe spend some time with this code and just really try to get an understanding of what's happening here. Okay, and now we're gonna build out another file. So what I want you to do is navigate to scripts, serialize, and then drag out student coordinator and student coordinator reference. Essentially, this is the code that's gonna allow us to paginate through the submissions, the form submissions. It allows us to fetch those items and render them in pages essentially. So that way we're not just displaying everything at once. It really helps with the loading time of our application. And this is really just good practice when you're building, honestly, any kind of front-end application that requires you to fetch, possibly a large amount of data from another resource. So that being said, let's get started. Okay, so what we're gonna do first is we're going to import a few libraries. So one of them is going to be BS58. And I do recommend you type this out manually, as that helps with memorizing the types of dependencies we use, because you'll most likely be using these dependencies a lot as you build out your applications. But call me a hypocrite, but for the sake of brevity, I'm actually going to copy and paste those last two. Okay, now remember, you're going to be wanting to import student intro, right? The code that you wrote yourself, not the reference. I'm going to import the reference into this one just so that it works, but please go ahead and import student intro into the student intro coordinator class. Okay, so now we're going to define the on-chain program we're actually going to be interacting with and fetching this data from. Remember, we're submitting this form data to a custom program on-chain. So in order to interact with that program from our front-end application, we need that program ID. So student intro program ID equals, and you can just go ahead and copy and paste that. Fantastic. And then let's get started. So we're going to initialize an array of public keys, and it's going to be empty. And now we're going to initialize an asynchronous function called prefetch accounts, and it's going to take a connection, which is information we'll get from the user's wallet that they connect to our application. It essentially tells our app which Solana cluster they're connected to, DevNet, mainnet, etc. And so in this function, we're going to use this getProgramAccounts function to ping our student intro program ID, that custom on-chain program, and then grab data from that program essentially. So here we define our data slice, and then we define some filters for the data that we are fetching. So let's go ahead and do that. So we're going to define a variable called accounts It's going to be an asynchronous operation, so we're going to use the await keyword. And then we're going to use the getProgramAccounts method, open up some parentheses. And then we're going to instantiate a new public key and pass in the program ID that we defined earlier. And then we're going to open up some curly brackets and pass in some properties that are kind of define the data we want to fetch from the blockchain. Now this piece of code that I'm writing now with the question mark and the colon, this is called a ternary operator. So if you're new to JavaScript, you might not have seen something like this before. Essentially, it's an if-else statement. And then we're going to open up another pair of curly brackets. I'm going to put the offset to 5 and the amount of bytes of this data that we're fetching. Just like so. Okay, fantastic. And so now that we've fetched this data, so here we fetch the data and I guess you could say define length of data, right? Now we're going to sort the data. Okay, using the sorts function. And if you get an error, don't worry about it too much. That's really a TypeScript issue. Your code should work. So right now, we're going to define two variables, length A and length B. And we're going to initialize that to 0. Just like so. And so what are we doing here? Well, Borscht adds an unsigned 32-bit integer at the beginning of the string. And so we create a data slice with a 4-byte offset, right? Because there are 4 bytes in an unsigned 32-bit integer. So let's go ahead and do that. Const equals the data inside account A. We're going to slice that. We're going to start at the 4th index, and we're going to add 4 just like that. And again, start at the 4th index and add 4. And now we're going to return data A compared to data to that item. Okay, fantastic. Oops, one little typo. Okay, great. And now finally, oops, I had a small typo there. This account equals accounts.map account, and then we're going to return the public key for each account. Okay, yeah, so we're looping over the array of accounts. Loop over accounts, return pub key for each account. Fantastic. So here we're prefetching the accounts, and now we're going to fetch a page. So you can think of a page as a collection of accounts. And so let's go ahead and define that. Again, this is going to be a static asynchronous function. It's going to take a connection string again, connection. It's going to take a page, another variable called per page, how many accounts per page, another item called search, and then reload, which is a Boolean value. and that's going to be initialized to false. It's going to return a promise because this is an asynchronous operation. And it's going to be a promise of a list of student intro objects. You can think of this as a list of student intro objects, right? We have 1, 2, 3, 4, 5. So that would be, if you kind of want to map it out in a data structure in your head, an array of 5 student intro objects, just like so. Okay, let's define the business logic in this function. Well, we're gonna write a condition saying if the list of accounts is empty, right? If the length is equal to 0, then we want to reload. And then we're going to, or if reload is set to true, then we're going to prefetch those accounts just like so. Now, we're going to create a new variable called paginated public keys. And then we're going to slice our list of accounts. Just like so. And then we're going to say if the paginated public keys is also empty, if it's nothing, if it's equal to 0, then we're just going to return an empty array. And we're going to create a new variable called accounts. It's going to be asynchronous, so we're going to use the await keyword. And we're going to use this method get multiple accounts info. And we're going to pass in our list of paginated public keys. Now we're going to create a constant variable called student intros. And we're going to use the reduce method, a very useful method in the JavaScript ecosystem. If you're unfamiliar with it, I highly recommend you look into it. Has nothing to do with blockchain. It's really a JavaScript thing, but I love the reduce method. I use it a lot, and it's kind of misunderstood, but that's beyond the scope of this conversation. So anyways, we have an accumulator, right? So the reduce method takes an accumulator argument, and then this account is kind of like the current item within the array that we're focused on. And now we're going to instantiate a new variable, intro, student intro. And then we're going to use that deserialize method we defined on our student intro class. We're going to pass in that account. Now this question mark says, if this account exists, then let's go ahead and access that data item within that structure. Now we're saying, if this item is null, if it doesn't exist, then we're just going to return the accumulator, that array. Otherwise, we're going to return that list of items plus the student intro accounts that we deserialized. Now, why is this giving us a bunch of red error messages? Because the reduce method requires some initialized state variable to update as this function executes. And in that case, we are going to initialize an empty array. Okay, so I hope that makes sense. Essentially, we have an empty array. We're looping over a list of student intros. And then as we loop over each student intro in that list, we're deserializing it and adding it to our array, essentially. Okay, fantastic. Well, let's go ahead and return that item, return student intros, just like that. And just like that, you've pretty much completed your student intro coordinator. And with that, we can get to the actual web page where we build out our business logic for sending and fetching the data from the blockchain, and then building out our UI that you see here. So let's go ahead and get into that right now. So what I want you to do is I want you to go into your folder and navigate to pages, navigate to Serialize, and then drag out the starter file, and then right next to it, drag out the finished file. So that's Serialize starter and Serialize finished. And you can go ahead and just delete those parentheses in the finished file, open up some curly brackets, open up a return statement and some React fragments, just like that. Oops. Open up some parentheses, React fragments, and delete that boilerplate import. And what we're going to do is we're going to import these libraries. So let's go ahead and type that out. Of course, this is a React application, so we're going to import React. We're also going to import this new item. FC stands for functional component. I don't think we've used that before in this course, but because this is a TypeScript application, we're going to go ahead and use that FC type information. We're going to import the use connection and use wallet functions from the wallet adapter React library. And then we're going to import Toast, which has nothing to do with blockchain, but it allows us to display user-friendly information on our web page. And now what I want you to do is go ahead and copy and paste these local imports here, but delete the reference. So we're importing our student intro and our student intro coordinator, just like so, because we've built our own together. And just like that, you should have no error messages. Let's go ahead and build our app on our local application. You can go ahead and navigate to the starter file. You should see an empty page, and we'll see the page come to life as we build it out. But first, we're going to focus on our business logic. So this is a React application. In any React application, the first thing we want to do is instantiate our state variables using the use state React hook. So we're going to do just that. Or the first state variable is going to be the name, and we're going to pair it with a function to update that name. And because this is a TypeScript application, and I'm going to go ahead and get into the habit of defining the data type of our state variables. So remember, if you're new to React, the state variables are the variables that are going to be updated throughout the lifetime of our application, right? And so this will become more obvious to you as we build out the app. React use states. Now the type of this is actually going to be student intro, a list or an array of student intros initialized to an empty array. And this is going to be a number. It's the number of pages we have. We're going to initialize that to 1. And then we're going to create a search parameter here. And that's going to be a string. Fantastic. Okay. Now that we've initialized our state variables, we are again going to define the program ID that we're going to be interacting with. So target program ID. I believe in the other file I gave it a different name, but you can check for yourself. It's the same program. This is the same program ID that we used in the other file. Okay, so let's continue. Now, if you've been following along with this course, you should recognize these variables. We're going to extrapolate the connection variable from the use connection function that we imported, and then the public key and send transaction function. Oops. From the use wallet function we imported. Essentially, this allows us to access information from our wallet and interact with our wallet when we want to send a transaction to the blockchain. So let's go ahead and let's create some quick logic for creating a submission, right? So let's go ahead and do that. Create submission. This is going to be an asynchronous function. We're going to use that keyword. The function is going to take an event argument, which is essentially allows us, really the event argument can be used for multiple different kinds of things, but we're going to use it for preventing reloads in our React application whenever the user submits information from our form. Now we're going to create a new student intro object. We're going to pass in the name and their thoughts. And finally, we're going to use that await keyword, and we're going to call a function that we have not yet created, student intro, and we're going to pass in our student intro. Okay, fantastic. So let's go ahead and create the business logic to send a transaction to the blockchain. Let's go ahead and do that right now. So let's first add a few comments. Handles form submission, sends data to blockchain, and let's go ahead and continue. So our function is called handle transaction submit. We can call it handle transaction submission. I think that's maybe a little bit more semantic. This is also going to be an asynchronous function. It's going to take, as you can see, a student intro argument of type student intro. And let's go ahead and open up a pair of curly brackets. Now what we want to do, like in most of the other applications we've created in this course, is do some error handling. So in order for this application to even work in the first place, the user's wallet needs to be connected. So we're going to say, hey, please connect your wallet. And we're going to throw a message saying, please connect your wallet. Just like so. And now we're going to create a buffer. And we're going to serialize that information using that serialize endpoint we created on our student intro class. Just like so. Oops, I accidentally mistyped that. There we go. Okay, looks good. So creates buffer of input form data. Okay, fantastic. Now that we've created that buffer, we're going to instantiate a new transaction using the Web3 library. Just like so. And now, here's where we get into some more nuanced topic of conversation. So we're gonna calculate what's called a PDA, or program derived address. So what is a program derived address? Well, let's go ahead and type out this code and I'll teach you more about it. So we're essentially going to use a method on a public key, find program address sync for synchronous, meaning this is not an asynchronous operation. And we're going to pass in our user's public key. And then we're going to pass in another public key, but it's going to be that of the target program ID, essentially. So we're converting this target program ID from a string into a public key. That's essentially what's happening here. So, okay, what is a PDA? Why do we care? What's happening here? Well, let's figure out first, learn about the Solana account model and exactly what our application is doing. So what we're building, what you and I are building in this video, we're building the client, right? We're building the front end. And what we want our front end to do is to get some data. So this is going to be our data. Let me go ahead and color that and give that a label. It's going to get some data. The data, in our case, being the input form data. And it's going to submit that to a custom program on the Solana blockchain, right? Now, the question is, what is this program going to do with this data? Well, we want the program to store our data on the blockchain. And the way it does this is by creating a PDA account, a program-derived address. Now, for those of you that are coming from the Ethereum ecosystem, a program is just another word for smart contract. So when you hear program, think smart contract. But what's very, very important to note about Solana programs or Solana smart contracts is that state, right, general data and code, executable data, are stored separately on the blockchain. So here we have a program, right? And separate to that, we have an account, which stores general information. So very, very, very important to note that code and data on the Solana blockchain are stored separately in two different objects, right? And so if you want to learn more about that, I have some notes here that you can reference. I'm not going to read that out to you because that's a waste of time, and you can do that on yourself. A link to this note page will be in the description of this video, so you can reference that on your own time. But very, very important. Okay, so the program, so we pass this data to the Solana blockchain directly to this custom program on chain, specifically this one. And this program is going to generate an account, a program-derived address account, to hold our data, our form submission data, essentially. So more on PDAs. What are PDAs? A PDA is a type of account on Solana that is associated with and owned by a program, right? So here's a graphic here that maybe explains it a little better for you visual learners. So if user one, when they interact with our application, right, and they connect their wallet and they press, here, let's go back to that preview page. So user one's going to connect their wallet, they're going to type in their information, they're going to press submit. What's happening here is that they're sending that information to the program, and the program is going to generate a PDA that's mapped to their wallet, essentially, right? So the PDA maps to the user that created that submission, and it maps to the program that created the PDA, right? And you can see that here. So this is color coded, right? User two comes, they send their form submission to the program, and the program creates a PDA mapped to user two, and of course mapped to the program that created the PDA. And again, user three comes in, submits some data to the form, the program creates a PDA mapped to that user and mapped to the program. Okay, so for those of you that are back-end developers that are familiar with database design, relational database design, this concept should kind of sound familiar to you, right? You can think of the address of the public key of the user's wallet and the program ID as like a joined keys, right? Joined primary keys. Okay, fantastic. So hopefully that makes some bit of sense. Let's get back to the code. So we're calculating this PDA using the public key of the user's wallet, like so, and the program ID, like so. We're going to calculate that. And then once we have that PDA, we can go ahead and create the instruction that essentially tells, that defines what kind of operations we want to perform on the blockchain. So let's go ahead and instantiate this instruction object, new web3 transaction instruction, open up those parentheses and those curly brackets. and we're going to pass in 3 items: a set of keys, some data, which is going to be our buffer, right? The buffer being the form submission, and the program ID of the program we're sending this transaction or these instructions to. And again, that is going to be our custom on-chain program. Now the keys. Okay, so this is probably the most intimidating looking part of the instruction object. What are the keys? Well, in Solana, unlike Ethereum, for those of you that are coming from Ethereum, the transaction specifies each and every account that we interact with, right? So if a transaction is supposed to read from some account or write to an account, right? Edit the information on account. If it's supposed to interact with some kind of program on the blockchain to perform some kind of operation, whatever entity on the blockchain that our transaction is concerned with, we have to specify each of those items within the keys array of our instruction. So let's go ahead and do that. So I challenge you to actually pause this video, look at each one of these objects, and just determine from intuition and from reading the rest of the code which accounts we are interacting with and why. So go ahead and pause. Okay, I'm going to assume you paused. I hope you did, to challenge yourself. Let's go ahead and walk through this together. So in each object, we're going to define the public key of the accounts we're interacting with. So the first one is going to be the public key of our user's wallet. Are they a signer? The answer is yes, true, because as you saw earlier when I demonstrated the application, when you submit the form, you have to sign for that transaction because you're creating state on the blockchain, and the user is a signer, right? Now, is this account writable? False. It is not writable. Okay, next. What's the next account? Well, the PDA, because we're creating a new account on the blockchain, we're creating a PDA. So is this account a signer? Well, false. They're not signing for anything. But is it a writable? Yes, it is writable. We are appending data to this account. We're creating it, right? It's writable. It's being edited or edited. Sorry, I hope my English isn't too horrible for you. Okay, last but not least, we're going to include the system program. Because we are creating new information on the blockchain, we have to invoke the system program. The system program is one of the core programs on Solana, developed by the core team at Solana. It's responsible for a lot of very core basic operations. I recommend that you actually maybe give it a Google, look up what the system program on Solana does, what it's responsible for. You're going to be using it a lot when you develop your Solana applications, whether that be front-end or back-end. Okay, fantastic. So now that we have our instructions, let's go ahead and add that to our transaction. Just like that. Okay, fantastic. And finally, we're going to write the asynchronous operations to send our data to the blockchain. So whenever we're creating asynchronous operations in JavaScript or TypeScript for that matter, I like to use the try catch blocks. On the try block, we're essentially write code that you want to perform. In the catch, code that executes if process fails, and the finally, code that runs regardless or always, right? So regardless if our code succeeds or fails, this finally block is always going to run. And I like to use finally for resetting the state of our application. Pretty simple. People don't usually talk about the finally block, but I love to use it. So what if our app fails? Well, we want to display that error to the user, just like so. Transaction failed, and we can log that message to the console for the developer. like so. But what exactly are we trying to accomplish? Well, we're going to use that send transaction function to send our transaction to the Solana blockchain. Okay, let's do that. Send transaction, and we're going to give it the transaction object and the connection that we got from our wallet. Okay, awesome. And you can add this console message, not super important, but maybe for your own debugging purposes, if this app fails on you, go ahead and do that. And we also want to throw a success message using toast, just like so. Okay, fantastic. Now we've pretty much written almost all of our business logic. We have one last item down here. We're using the use effect hook from the React library. So let's go ahead and define that. Use effect. We're going to open up an arrow function and then some curly brackets. And then we're going to add an array of variables we want to watch for state changes. And that's going to be page and search. And then we're going to define some logic we want to execute whenever these variables that we're watching, whenever their state changes, right? So for example, in this application, whenever I press next or the previous buttons, that page information changes, and this executes this code, which says, which is invoking our student intro coordinator, and that fetch page function in our coordinator. And then we're going to say how many student intros we want to fetch so that we can paginate through, right? And we're going to set our student intros state variable with that information that we fetch essentially. And right here we're fetching 5, but you know, if you want, you can fetch 6, 7, 8. It's really up to you, but I think 5 is a good number. Okay, so just like that, let's add some comments. Fetch student intros, paginate them. Okay, fantastic. Now, really all we have left is to build out the UI of our application. So let's go back to our starter file in project 4. It should still be empty. And let's make some magic. So what I want you to do is open up some main tags, and we're going to give it some styling using Tailwind CSS. And then we're going to give it some text. And now what we're going to create are 2 sections. One for our form, and then one for the list of student intros. So we can put here student intros, and then for this first section we can put form. Okay, fantastic. So let's go ahead and give this section some styling. It's going to be a grid, and on any screen larger than small, this grid's going to be made up of 6 columns. Each column is going to have a gap of 4, and it's going to have a padding of 4. Now we're going to create the actual form. We're going to round out those corners. It's going to be as tall as its contents. We're going to give that a padding of 4. Give it a custom background color, just like so. You can really give it any background color, but I defined a custom background color. And then we're going to determine how much width it takes on screen, depending on the screen size. So on larger screens, it's going to start at the 2nd column and end on the 6th. Fantastic. Now within this form, we essentially have 2 parent divs. Oops. Now this first div is going to be the header, and this second div is going to contain our inputs. So within the header, we have our title and our submission button, but first we're going to give it some styling. So we're going to use flexbox and justify between and item center to vertically center our items and then spread them apart within the div. We're going to create an h2 element. That's going to be the title of our form. And then we're going to have some styling. I'm going to bold the fonts, increase the size of the text, and give the text a custom color. You can give it any color you want. And then we're going to include a button. Now this button is going to have a few things. It's going to have some styling, and you can go ahead and copy and paste this styling. I'm not going to hold it against you if you don't want to type it all, because the most interesting part of this button is what's happening above that styling. So we want to have some disabled clauses for the button. Essentially, we want to say if the name field is empty, or if the thoughts field is empty, then this button is going to be disabled, right? So you have to fill in both input fields in order to submit your form. Now here I'm using this onClick parameter. Actually, because this button is within a form, what I want you to do is just use that type parameter and use submit. And then up here on this form tag, what I want you to do is on submit, define that event variable using arrow function and pass in the create submission function and pass in that event argument. Fantastic. Okay, so simple enough. Let's go ahead and give that button some text, submit. And now we can get on to the input fields of our form. So let's give this some styling, some bottom padding. And we're gonna have two divs, one for each input field. Let's go ahead and start with the first. We're gonna give that first input field some spacing from the top. And a little title. We're gonna give that title some styling, make it italic, make that text small. And then we're gonna provide that input field. So it's gonna have an ID of name because this is where the user is putting in their name. It's gonna be of type text. The placeholder is gonna be something semantic to give the user an idea of what exactly, what kind of information they're providing. And then we're gonna give it some styling, give it some vertical padding. We're gonna make it transparent, outline none. For aesthetic reasons, resize none. We're gonna give it some border information. And fantastic. Okay. Now, this next parameter is very important. You're going to be using it a lot for your React application. It's called onChange, and essentially it says whenever the state of this input form changes, we're going to execute some logic, and we're going to define what logic it's going to execute within these curly brackets. And essentially, we're going to be using that update function for the name state variable, and we're going to pass in the event target value. And so we're saying whenever this input form changes, whenever its state changes, right? So I'm changing its state, as you can see. We're going to execute this code. We're going to use this function to basically populate this name state variable with the value of this form, right? So if I type in Nathan, the state variable of name is going to be Nathan. If I type in Bob, the state variable is going to be equal to the string Bob. So pretty simple, but pretty important and very, very useful. You're going to be using that a lot in your React applications. And the value of this input form is going to be tied to the name state variable. Okay, awesome. So let's go ahead and open up this other div. We're going to give that some vertical spacing as well from the top item. We're going to give it a little title. Some styling. Now this might seem a little bit repetitive, but I highly recommend you bear with me and type it all out yourself, because practice makes perfect. And if you're new to Solana applications or React applications, then you want to get all the practice you get, because this stuff can be very confusing. Okay. It's gonna have a transparent background, outline of none, resize to none. We're gonna pass in some border information as well, oops. And we're gonna color the bottom of the border. Okay, fantastic. Again, on change, we're gonna update the thoughts state variable with the event target value of this input form. And the value of this input form is going to be associated with the thoughts state variable. Fantastic, so just like that, we've pretty much recreated our form perfectly. Your UI should look something like mine. If it doesn't, maybe pause this video and spend some time on debugging, you know, what you got wrong, what you might have missed. But if you're looking good, congratulations, awesome job. This is not easy stuff, I promise you. Especially CSS, people don't give it enough credit. CSS is so meticulous, right? You have to get it like exactly right, otherwise your UI just can look so off and so weird. Okay, so now we're gonna start into that building that student intros section. This is the last component of our application. Let's go ahead and get started. So again, this is going to be a grid. It's going to have one column. On small screen sizes, on anything larger than small, it's going to have 6 columns. Each column is going to have a gap of 4 and horizontal padding of 4. We're going to have just one large div. Let's open that up. Let's give it some styling. And this is going to be only as tall as the content that populates it. Let's go ahead and give that a custom background color. Oops, let me fix that. And let's go ahead and define the starting and ending points on larger screen sizes. Okay, awesome. Now we're going to provide a title. And we're going to give it some spacing from the bottom. And this title is going to be Meet the Students, right? Or you can really give it any title you want. Obviously, that kind of information isn't super important. We're going to open up another div, and then within this div, we're going to have 2 divs, essentially. So let's go ahead and open that up. So div 1 and div 2. So what is this div 1? Well, essentially, this div 1 is going to be the list of student intros. And this div 2 is going to be the pagination buttons that we're going to use to paginate between pages of student intros. Now, if you're new to React, these sections might seem a little bit confusing or intimidating. Don't worry, we're going to explain it and walk through it right now. Okay, so what's happening? Well, let's go ahead and open up the list of student intros div. We're going to give that some spacing from the top, and we're going to open up some curly brackets just like that. Now we're going to grab that student intro's state variable that we defined at the top of our functional component, and we're going to map over that array essentially, right? So if you scroll to the top, this is an array of student intro items. We're going to map over that array, which means iterate over that array. And then for each item in that array, we're going to grab the student intro that we are currently mapping over. And we're going to grab the index of that item. Go ahead and define an arrow function, open up those parentheses, not curly brackets, parentheses, because we are doing an implicit return. And we're going to conditionally render this div that you see here. So this is our condition, as I've highlighted. Let's go ahead and type that out. So we're saying if the name exists in this object and the message exists within this object, then, ampersand ampersand means then, we're going to render this div. And because we are programmatically creating these items, we need to provide a key, and we're going to use string interpolation to do that. So we're going to use $ curly brackets student intro name dash, and we're just going to provide the index essentially. Why? Because we want to include a key, but technically people can submit the same name. The technical details aren't super important. Now we're going to provide a custom background color for each of these divs so it stands out against the background. We're going to give it some border information, some vertical spacing, some padding, and we're going to run those edges so it looks a little bit aesthetically cool. Now we're going to provide some title information. We're going to give it some coloring to make it stand out. Feel free to experiment with the styling of your application. And we're going to pass in, using curly brackets, the student intro name just like so. So this way we can programmatically insert variables within our UI. And we're going to do the same here with our message. And we're going to give this some styling as well, text small, and some spacing from this h4 tag. Okay, so last but not least, let's go ahead and create the buttons and some of the logic to paginate through our array of items. So let's go ahead and give this div some styling. We're going to space it from this top div. It's going to be a flexbox item, justify between. Why justify between? Because this way we can space out the next and the former buttons from each other. Okay, now we're going to open up some curly brackets, and we're going to use, skip some stats. So we're going to have two divs, one for our next button, and then one for our previous button, just like so. Okay, fantastic. And so we're going to open up some curly brackets, and we're going to do some conditional rendering. If the page is greater than 1, right? So if we're on the second page or whatever, then and only then are we going to render this previous button, right? Because you don't need a previous button if you're only on the first page. There is no previous to that, right? So that's why we do some conditional rendering, and then we're going to access this state updater function that we defined earlier, and then we're going to update the state of this page state variable. Now we're going to define some styling. The background is going to be Helius orange, it's gonna have rounded edges. We're gonna define the width, vertical spacing. The font is gonna be bold. And we're gonna have some hover state information. It's always very, very useful and important to add hover states to your buttons, especially for desktop applications. Essentially, this is going to change the aesthetics of our buttons whenever the user hovers over them. And now we're going to create the last UI elements of our application. Let's open up those curly brackets. And we're going to do some more conditional rendering. So we're going to say if the student coordinator, or if the length of the accounts that we fetched. So we're going to say if the length of the accounts that we fetched is greater than 5 times the page that we're on, then we're going to render this next button. And again, we're going to update that state variable, but instead of decrementing, we're going to increment. We're going to add some styling information that's actually pretty much exactly the same as our previous button. So if you want, you can actually just copy and paste that. And we're going to add a disabled clause saying if the list of student intros is empty, then this next button should be disabled. Okay, fantastic. So just like that, you should have a brand new application that works like functionally exactly the same as the one that we tested earlier. I'm gonna go ahead and create a new Phantom wallet. So let's go ahead and do that. I'm gonna call it test4. I'm gonna copy and paste the public key to my wallet, and I'm gonna send it some Sol. So let's go ahead and send it some Sol. Let's see, how much Sol do we want to send? Let's send it just a little bit of Sol. Or on the testnet, let's connect our wallet, accept that connection, and finished video project. Maybe give me a shout out when you submit your project. Let's go ahead and submit that. Sign for this transaction. Boom, transaction successful. And happy ending. Now, if you want, you can go into your console. You should see the URL to our transaction. You can see that it was successfully submitted to the Solana blockchain and finalized on the DevNet. So awesome. Thank you so much for following along with this video. I hope you learned something new. The concepts that we covered today were a little bit challenging and new, especially if you're new to Solana development. So please take time with these concepts. Maybe rewatch this video at a later time to really soak in what you've learned. Thanks for watching this video. Please feel free to get connected with me on X, to connect with the Helius team on Discord, or to learn more about Helius on our website. See you in the next video. Peace out.